So this question is for those who are up for a bit of a challenge. It's quite a difficult question. A student gave it to me this week, and apparently it is the last question that was in a Hong Kong maths exam. So see how you go about it. This is how I approach the question, but I'm sure there's there is absolutely lots of different ways you could go about it. So to find the equation of a circle whose center passes through y equals 5 and is tangent to y equals a half x and y equals negative a half x. So the first thing that you do when you have these type of questions is give it a sketch. You don't have to, but I did. And once you give it a sketch, you can quite clearly see that the center is going to be 0 and 5 for my circle. Now this is going to be important because now I can come over here and write down the general formula, not the general formula, but rather just my equation for a circle, which has its h's and k's. And we know that my h's and k's are going to be where my center is. My h and k is where my center is. And we know that it's going to be 0 and 5. So therefore, by subbing in these values into this equation, I could say that my circle is going to be x squared plus y minus 5 squared equals r squared. Now, this is where the difficult part of the question comes into play, because we need to figure out what my radius is going to be. Now, the best way to think about this is that I have a line here. I could use any of these green lines, but I'm just going to use y equals a half x. I have a line here, and I have a point here, and I need to figure out the shortest distance between this point and this line. That's going to be my radius. Now, to do that, I'm actually going to have to first find an equation for a straight line that is going to be perpendicular to the line y equals a half x and passes through 0 and 5. So it's going to be somewhere about here. So this is a line, sorry, this is going to take me some time. This is a line that is perpendicular to y equals a half x and also passes through 0 and 5. So if I was to come here and I could say this is going to be perpendicular to it. So it's going to be a right angle there. So let me scroll down a bit. I'm trying to find this line right here. And I'm starting with y equals negative a half x. So my gradient is going to have to be perpendicular. And we know that my gradient, the form for finding perpendicular gradient, is going to be gradient times gradient equals negative a half. This would be m1, m2. So that means that my gradient of that, my new line, will be, let me do it in blue, will be y equals 2x, and so my gradient will be 2, and I don't know exactly what my c will be at the moment, but I can find it by subbing in a point 0 and 5, because I know that lies on my new line. And if I were to sub that in, it's quite obvious that my line will be y equals 2x plus 5. So that is going to be the equation of my new line. So I can come over here and say, well, this line is going to be y equals 2x plus 5. Now I need to find this dot right here, this point. I need to be able to find this point, because once I find this point, all I have to do is use my distance formula to find the distance between these 2 points right here. But I need to find it. So I need to find my coordinates for this point. Now, we know that this point exists as the intersection point between y equals negative a half and y equals 2x plus 5. So to find it, all I really need to do is set those two equal to each other and then solve. So I'm going to come over here and let me just delete this. Let me just get rid of all this. So just so we're dealing with a nice fresh page. So I have negative a half x and trying to figure out where they intersect for these two equations. So I do some nice rearranging. I'm going to get negative 5 on this side. I'll get 5 on 2x on this side. So I will get negative 10 equals 5x. So therefore, negative 2 equals x. So that's what I'm dealing with. That's going to be my intersection point for the x-coordinate. I need to find my y-coordinate, and all I would have to do is sub that into either one of these equations here. So if I subbed it into here, I'm obviously just going to get 1. So my point of intersection will be -2 and 1. So let me get my red, and I could put that here, -2 and 1. And that makes sense. I've actually drawn it perfectly here. It's going to be -2 and 1. Perfect. And then we could go over here, would be, because I know it's going to be symmetrical, 2 and 1. So now to find the radius, my radius, all I'm going to do is use my distance formula, which we know to be normally you say 2, x2 minus x1 squared plus y2 minus y1 squared. So my radius will be, -2 minus 0 square root will be 4, plus 1 minus 5 will be -4, square root will be 16. And I've done that correctly. 2, 0, good, 1, 4, good. So I'm going to be 4 plus 16, which is going to be my radius is going to equal to the square root of 20. So now I'm going to find out what my r square valued will be. R squared will just be 20. And as you can see here, this is my r squared value. And that's exactly what I needed here. So I could rub this out and replace it with 20. Let me do it in black, 20. So that would be my answer. So again, let me know if you approached it a different way, but I think this is a fairly efficient way to answer this question. Hopefully you enjoyed it. Again, this question wouldn't be for everyone, just for those who are up for a bit of a challenge. Perfect, thank you very much.